In this video, we'll be talking about how far away something is. In other words, how do you find the distance from one point to another point? So some questions to consider for real life application when we talk about distance is, how does your GPS know how far it is from your house to your friend's house? How does that calculate the distance? Another question you can ask is, let's say you're the quarterback of Cy Ranch and your receiver is standing 10 yards left of you. You hike the ball and your receiver runs straight for 15 yards. How far do you need to throw that football for him to catch it? And another question to consider that you should be able to answer by the end of this video is, you're in the marching band. Your spot for your next set is 20 feet forward and 5 feet to your right. How far away is the spot? Using distance, we can calculate all of these distances. Of course, that's the distance formula that we're going to use. First, how would you try to solve these problems? So going back and thinking about being the quarterback and throwing the ball, and being in the marching band. Pause the video for a second, draw a picture of these situations, and see if you can figure out how you would solve these problems. Okay, welcome back. So, if you had tried to solve those problems, you would have drawn a picture, and hopefully you got a triangle when you drew the picture. Now, right triangles can always involve the Pythagorean theorem. So first ask yourself, what is the Pythagorean theorem? And second, how could that Pythagorean theorem be applied in these situations? We know that the Pythagorean theorem is a squared plus b squared equals c squared when you have a right triangle, where a and b are legs and c is the hypotenuse. If you go back and if you imagine that we're talking about the football question, in the football question, you're the quarterback standing here. You hike the ball, your receiver started here, 10 yards left, and ran a route that went 15 yards forward. So the ball that you threw had to go from this point where you were to your receiver here. And that would be the distance you're actually looking for. Now, if you kind of drew a dotted line showing, well, that's how far you were, and a line where your receiver ran, you would see that it actually makes a nice right triangle. So the Pythagorean theorem applies perfectly to this situation, in that the receiver is 10 yards left of you and ran a route 15 yards forwards. So Pythagorean theorem states a squared plus b squared equals c squared. So you know that 10 squared plus 15 squared would have to equal d squared. And you could solve that easily. 100 plus 225 equals d squared. Add them up. And finally, to undo a square, you take the square root. So if you typed in the square root of 325 into your calculator, you'd get about 18.02 yards. So you'd have to throw that football 18.02 yards. So that's how the Pythagorean theorem could easily apply to a question like this. So take a second, practice these out, and see if you can solve using the Pythagorean theorem. Pause the video and try it. Okay, so we know a squared plus b squared equals c squared, where a and b are the legs, in other words, the sides that connect to make the right angle. So 5 squared plus 12 squared equals x squared. 25 plus 144 equals x squared. 169 equals x squared, so square root it. 13 equals x, so that distance would be 13. You might be tempted to say that it's 17 by adding it up, but that's why you need a Pythagorean theorem to figure that out. And let's try this one. The two sides that form to make a right angle are the legs, so 34 squared plus 55 squared equals x squared. Okay, so this is one that you'd solve, so 34 squared is 1156 plus 55 squared, which is 3025, equals x squared. Add those up. 4181 equals x squared. And finally take the square root, and you get x is about 64 points. Let's see, square root of 4181, 64.66 miles in this case. On the other one, I really should have kept feet. So the Pythagorean theorem could be very useful in figuring out the distance between 2 points. Okay, so at this point, I'm going to stop the video so you can take that, and we'll start up and we'll formalize the actual distance theorem.